In China, a humanoid robot accomplished something humans trained for years to master, and no humanoid had ever achieved it before. In the US, another humanoid casually distributed Christmas merchandise and conversed back. A robot dog sold out in under an hour like a new smartphone launch. Factories started replacing skilled workers with humanoids at scale, and one of the most famous robots globally is about to step onto a worldwide stage next month. And it all begins with a robot in China accomplishing something that appears simple until you realize it's one of the most difficult things a machine has ever been requested to do. On December 22nd, TARS Robotics displayed a humanoid robot on stage at a live event. And this robot didn't lift containers, didn't stack crates, didn't walk around waving at attendees. It sat down and performed hand embroidery, genuine embroidery. It threaded a needle, utilized both hands, and stitched a logo live before an audience. Now, if you've never stitched anything in your life, that might not sound impressive, but the moment you consider what's actually occurring there, it becomes kind of wild. You're dealing with thread that stretches and twists, fabric that moves and deforms constantly, and movements requiring submission over an extended sequence of steps. One tiny mistake and the thread snaps, the stitch misses, or the whole thing collapses. This kind of task has been a nightmare for robotics for decades. Industrial robots are amazing at rigid, repeatable jobs. Pick this metal component, place it there. Repeat it again 1,000 times. But soft materials break everything. They change shape, they resist unpredictably, and they require constant force adjustment in real time. That's why until now, long, delicate, two-handed work like this was seen as basically off limits for automation, and that's what made this demonstration so important. The robot moved through the whole process smoothly, staying stable the entire time, with zero signs of hesitation or struggle. Both hands working together, adjusting force, tracking the needle and thread visually, and staying stable the whole time. That's not just motion control, that's embodied intelligence working as a system. When robots master thread, they master everything delicate. People inside robotics immediately recognized what this meant, because once you can accomplish this, you're suddenly not just discussing embroidery, you're discussing wire harness assembly, precision electronics, fine mechanical assembly, all the stuff factories still rely on skilled human hands for. At the event, TARS Robotics CEO Dr. Chen Yaolun explained how they achieved it, and the way he described it actually aligns with a bigger trend we've been witnessing across AI lately. He called it a data, AI, physics trinity approach. Basically, instead of treating data collection, model training, and physical robots as separate worlds, they connect everything into one continuous loop. They collect detailed real-world operational data using their Sense Hub platform. That data feeds into their embodied AI model, the AWE 2.0 AI World Engine. And here's the key component. The model isn't trained to accomplish one specific task. It's trained to learn general physical skills, balance, coordination, force control, vision under uncertainty, stuff that transfers from one job to another. Those learned skills then run directly on their humanoid robots, the T-Series and A-Series platforms. Chen also stressed something that matters way more than people realize. The digital to physical gap is small. What the AI learns during training actually carries over into the real world, which is why the robot held together on stage and performed the task without falling apart under real conditions. The system follows classic AI scaling laws too. As more real-world data flows in, performance improves across multiple tasks at once. Their chief scientist, Dr. Dingwen Zhou, discussed how success rates jumped across different scenarios simply by scaling data and refining the model architecture. The long-term goal here, obviously, isn't a robot that can stitch logos. It's robots that learn adaptable skills and carry them into new environments without being reprogrammed every time. And the craziest component? TARS Robotics was founded on February 5th, 2025. In under a year, they went from concept to live humanoid demonstrations, showing capabilities people used to declare were years away. Investors clearly noticed. The company raised $120 million in an angel round, then followed that with another $122 million in an Angel Plus round. Now, at the time this was happening in China, a clip from the US revealed how far humanoids have come in a much more everyday setting. On December 23rd, right before Christmas Eve, Figure AI's CEO Brett Adcock shared a short video showing him interacting with the company's latest humanoid, Figure 03, in a simple, unscripted setting. He starts by asking the robot where it was built. It answers clearly, saying San Jose, California. I was built right here in San Jose, California. He asks which generation it belongs to. The robot says it's part of the third generation. There are 3 generations of figure robots, and I'm the latest one. When he asks which generation is best, it does the polite thing and says the third generation because it has the most advanced features. I believe I'm the best as the third generation with the most advanced features. Then he tests something more practical, visual recognition. He asks the robot to hand him medium and large shirts. The shirts are situated in different baskets. Figure 03 examines the setup, identifies the correct size each time, picks the right basket, and hands the shirt over correctly. Under the hood, this robot runs on Figure AI's Helix model, which is a vision language action system. That means vision, language understanding, and physical movement are tied together in one loop instead of being bolted together with rules. People watching the clip were impressed, but they also immediately noticed something else. The robot pauses for about 2 to 3 seconds before answering questions. That delay jumped out in the comments. One person even joked that it felt like dial-up internet and asked how Chinese robots compare. That reaction actually points to a real unsolved problem in humanoids right now: speech latency. Even when perception and manipulation are solid, conversational timing still feels off. The robot hears the question, processes it, generates a response, then speaks. Every step adds delay, and humans notice it instantly. Now, that doesn't mean Figure 03 is weak, far from it. The robot was released in October and is a big step forward for the company. It's smaller and about 9% lighter than previous versions. It has a softer exterior with mesh fabric and foam padding designed to reduce injury risk. It stands about 5 foot 6 inches tall and is built mainly as an assistant for household pick-and-place tasks. Physically, it's more capable too. In another clip released a few weeks earlier, Figure 03 showed quick starts, smooth turns, sharp braking, and even running. Forbes reported speeds between 4 and 6 miles per hour, which would beat the usual humanoid benchmark of 3 to 4 miles per hour. Figure AI itself gave a more conservative number of 2.7 miles per hour. Audio hardware has been upgraded as well, with larger speakers for clearer speech and less distortion. For power, Figure 03 uses wireless charging through coils built into its feet. It can recharge by standing on a charging pad at up to 2 kilowatts, and a full charge gives it roughly 5 hours of operation. So yeah, speech latency is still a thing, but overall, Figure 03 shows how far humanoids have come in everyday interaction, even in casual settings. Then, almost at the same time, something happened in the consumer space that surprised a lot of people. Humanoids went from lab demos to living rooms in 1 year. And that's just the beginning. We're witnessing robots transition from industrial tools to everyday companions, mastering skills that were considered impossible just months ago. If you want to stay ahead of the robotics revolution and understand which breakthroughs actually matter, make sure you're subscribed to the AI Edge. We're tracking every major development in AI and robotics, bringing you honest analysis without the hype. Drop a comment below. Which breakthrough shocked you more? The embroidery robot mastering delicate thread work, or Figure 03 casually handing out shirts and chatting? And if you want to see what's coming next in humanoid robotics, check out our deep dive on the latest AI technologies reshaping the industry. This is the AI Edge, and we'll see you in the next one.